Trigonometric identities and equations. Before you work through this video, you will need to know the trigonometric identities. If necessary, you should refer to the following video, which covers this topic. Thanks for watching this video, and don't forget to like, subscribe to the channel and activate the notifications. It's very important to the continuity of this channel. In addition to simplifying trigonometric expressions, there are also exercises in which you are asked to demonstrate whether the equality in trigonometric expression is true. This type of exercise is known as proving identities. To verify the trigonometric identities, we usually start with the more complicated side of the equation and essentially rewrite the expression until it has been transformed into the same expression as the other side of the equation. Guidelines for verifying a trigonometric identity. Only manipulate one side of the proposed identity until it becomes the other side of the identity. Typically, the more complicated side is the best place to start. That side will give you more to work with. In general, though this technique does not always work, the more complicated side of the identity is likely to be easier to expand. The reason is that, by its complexity, there will be more things that you can do with that expression. Look for trigonometric substitutions involving the basic identities that may help simplify things. Let's see how it works. Prove the following identities. To prove this identity, we transform the left side into the right side because there would not be much that we could do with the right side of that identity. It consists of a single term, cosine of theta, that offers no obvious means of expansion. We rewrite cotangent in terms of sine and cosine. We see that, in fact, the left-hand side is equal to the right-hand side, so the equality is true. There is no obvious way to simplify this expression, but the left side looks more complicated, so we will use the Pythagorean identity for the cosecant. Then we use the reciprocal identities. And finally, we use the reciprocal identity for the cotangent and the quotient identity for the cosecant. Since the two sides are equal, we have proved the identity. To prove this identity, we begin by rewriting the left side in terms of sine and cosine. Then we simplify by finding a common denominator, changing to equivalent fractions. After adding the fractions, we use the most important Pythagorean identity. Then we write as separate fractions. Finally, we use reciprocal identities. We now will see how trigonometric identities are useful to solve trigonometric equations. If there is more than one trigonometric function in the equation, identities are needed to rewrite this equation so that it contains only one trigonometric function. The next examples illustrate this. Solve these following equations. We first need to rewrite this equation so that it contains only one trigonometric function. To do this, we use the most important Pythagorean identity. By using the identity, the equation has been transformed into one that involves only one type of trigonometric function, sine of theta. We apply the distributive law and put all terms on one side. This is a quadratic equation in which the variable is the sine of theta. It can be solved using factorization or the quadratic formula. Look at this equation. By using the identity for the secant square, the equation has been transformed into one that involves only one type of trigonometric function, tangent of theta. This is a quadratic equation in the tangent of theta. So write this in the standard form and then solve the equation. Look at this equation. To solve this equation, we use the reciprocal identities. Simplify and subtract 2 from each side. This equation does not appear to factor nicely, so we use the quadratic formula, remembering that we are solving for cosine of theta. Using the negative square root first, we see this has no solutions since the cosine cannot be less than -1. Using the positive square root, we see two solutions.